Okay, parents. So I wanted to record a couple of videos for you. You know, I got written on that. I want to record a couple of videos for you to help you to be able to assist your student as they are studying for the assessment. So this topic 4, is all about multiplying decimals. And so one of the things that I kind of wanted to help your students with today is finding an estimate for a decimal product and then finding the exact answer. So starting with the estimate, we are to round each decimal to the nearest whole number. So when I say to the nearest whole number, I mean to the nearest digit, like whatever that digit is in the ones place. So when we round, we find the place, move next door. If this is 5 or greater, we add one more. So this is not 5 or greater, so we're not going to add one more. So the digit in the rounded place stays the same and everything behind it becomes a zero, which we could write it like this, or we could write it like that. And then for this factor, this is 5 or greater, so we're going to add one more to the rounded place, and everything behind it becomes a zero, which we could write it this way, or we could also write it this way. Either way it goes, 1 and 25 hundredths times 4 and 5 tenths is about 5 wholes. So that's our estimate. Now moving to finding an exact answer for these exact same numbers, I'm going to show you the two main strategies our students have been using to do this. And so the area model, which probably is not very familiar to you guys because it was not familiar to me until I started teaching math, um, it's a little bit more involved. It takes more time to do than the standard algorithm that we are more familiar with. However, it is a more accessible model, and most students have really attached to that. So I want to make sure I explain it. So what we're doing, we're going to write each one of these factors in expanded form. And we're going to treat this instead of 1 and 25 hundredths or 1.25 as a lot of people would say, we're going to treat this as 125. So writing this in expanded form, 125 is 120 plus 5. And then on the side, we're going to write the other factor, treating this as if it is 45. So 40 plus 5. And then everywhere I have a line, I'm going to a plus sign, sorry, I'm going to draw a line. I have one here, so I'm going to draw a line. And then we end up multiplying everything on the top row by this number on the side. So we're starting with the 5. And your students know this quite well because we start this off at the beginning of the year when we're multiplying multiples of 10. We tend to focus on the non-zero digits, so thinking 2 times 5, which is 10. And then we want to count the zeros and write the zeros. Both of these are non-zero digits. But that's kind of how we are learning to think through this and make math a little bit easier for us mentally. So that's 4 with 1, 2, 3 zeros. And so everything on the second row gets multiplied by 40. On the top row gets multiplied by 40. So that's 8 with 2 zeros. And then 40 times 5, that's going to be 20 with 1 zero. From there, we're going to add all of these together. So see, I'll line them up like this. And what we're getting is called partial products. And while I'm here adding these together, I want to talk a little bit about partial products because that kind of made me think about vocabulary. This year we have been taking lots of vocabulary tests. I've been really drilling it because once students get to this grade, and especially as they get beyond it, being able to read problems with keywords in it and know what you're being told to do becomes very important. So you want to make sure that you are working with or quizzing your student on vocabulary, the vocabulary that is attached to each skill. And I always give the keywords for the vocabulary at the top of the note. So please ask your student to let you see their math notes from topic 4, which should all be clipped into their binder. So after I add up each row, I have the partial products for each row, and then I add them together, and that gives me the digits, not my answer, but the digits that I would see in the product or my answer. But because we are multiplying decimals, they have to go back into the factors, circle the number of digits behind the decimal, start at the end, and move the decimal that number of times. So that's what that looks like in the area model. So this is called the area model. And again, I know this is very different from what we learned, but this is the model in which students prefer to do this, and they are experiencing the absolute most success. So a lot of them just keep going back to this, and they are getting some of the things right. So this is the standard algorithm, which looks more like what we are used to, where we are multiplying everything on the top row first by this 5. So 5 times 5 is 25, write the 5, carry the 2. 5 times 2 is 10, plus 2 is 14, write the 4, carry the 1. And then 5 times 1 is 5, plus 1. I don't even know what that should be, because that should be A2, not. 5 times 2 is 10 plus 2 is 14. I mean, it's 12. Why am I doing this? Anyway, and actually, as I'm saying this, I'm kind of laughing at myself because I talk to the students a whole lot about how easy it is to make mistakes during math. And I think that we really need to normalize making mistakes, because it's really noisy out in the hallway right now. And just a little bit of distraction had me make a mistake that could have blown my whole answer up. And so, even just encouraging them if they're making mistakes and letting them know that that's part of the process and they shouldn't feel ashamed of it is a good thing. So then we get to the second row. The value of this 4, if it's in the tens place, is 40. And there's 1 0 in tens. So we write 1 0 here, and then we start to multiply. So everything on the top row is going to get multiplied by the 4. So 5 times 4 is 20. Write the 0, carry the 2. 2 times 4 is 8, plus 2 is 10. Write the 0, carry the 1. 4 times 1 is 4, plus 1 is 5. And so what you'll see, I made a mistake right there, but what you'll see is that the partial products that I have right here in the standard algorithm, the way we were taught how to do this, they match the partial products of the area model. And so even though it is a very strange thing to look at when you have been taught so differently, it is still very much so, you arrive at the same answer, and so it takes longer. But for us, it doesn't really matter how the kids get there as long as they are able to get to the correct answer. So I just wanted to throw that out there with the estimate and finding an exact answer for 3-digit by 2-digit. So I hope this helps.